Hello everyone, this is K. Anand Goud, Assistant Professor from Civil Engineering Department. Today's topic is tapes and ranging of survey lands. So after learning about these topics, we are going to apply the surveying principles to complete the chain surveying or leveling or contouring for accurate data collection. So coming to the lectures of contents of this lecture, the first topic is we are going to discuss about the tapes and then ranging of survey lands. So coming to the detailed description of tapes. Here tapes are used in surveying to take linear measurements. Okay, so we are going to measure the dimensions which are linear. Okay, from point A to point B. So if these dimensions are available, then we are going to use tapes, and tapes are used for more accurate measurement. Okay, so when you compare with the steel chains, these tapes are going to give more accurate results. So that is why we are going to give the tapes as one of the instruments for chaining. Next, they are available in different lengths and can be made of different materials. Okay, these tapes can be available in the different lengths like 10 meters, 20 meters, 30 meters, and the materials used for these particular manufacturing of tapes are different. Okay, depending upon the material, we are going to classify these particular tapes. The first one here, linen tape and cloth tape, and second one is metallic tape, and third one is steel tape, and fourth one is invert tape. Coming to the first one, linen type of tape. Here, this tape is also known as cloth tape, and it is varnished. It is varnished with the metal and strip made with a closely woven linen. So, coming to the first type of tape, here this linen tape is also known as cloth tape and is varnished strip made of closely woven linen. Okay, it is made up of the woven linen cloth, and the width of this strip is about 12 to 15 mm. Okay, the width of this particular linen tape is 12 to 15 mm. That means this is the width of the tape, and here you can see in this picture, this particular width will be around 12 to 15 mm, and it is available in different lengths such as 10 meters, 20 meters, 25 meters, 30 meters. Okay, so this particular type of tape is available in 10 meters, 20 meters, and 25 to 30 meters. And at the same time, we are going to get this particular type of tape in 33 feet, and 50 feet, and 66 feet, and 100 feet. Okay, now coming to the next point, both the ends of this particular linen tape are provided with the metallic handles, and the whole tape is wounded in leather or metal case. So this particular tape will be handled with the metal strip, okay, which is placed here. You can see in this picture, this particular handles are used for handling the tape, and this tape will be bounded in a metallic case like this. Okay, this is the metallic case. In this particular metallic case, we are going to place the linen tape. And next one, linen tapes are light in weight and easy to handle. Okay, these particular tapes are very light in weight and we can handle very easily. And these tapes may shrink when exposed to water. Okay, if you expose these types of tapes, and these particular tapes will be shrink, or else the dimensions will be changed, and they are also going to elongate when pulled. Okay, because it is a cloth, when you pull it forcefully, then it is going to change its length, or else it is going to elongate, and hence these particular tapes are not suitable for accurate surveying. So due to these particular problems we are facing while exposing to the environment, or else while pulling the tapes, we are not going to use these types of tapes for accurate surveying. and these are generally used for measuring offsets and for ordinary works. Okay, wherever you are going to uh, you want to use accurate results. Okay, you want to get accurate results, there we are not going to use, and these are used for measuring the offsets. Okay, measuring the offsets from one point to another point. And then for ordinary works, okay, very simple works, for very simple works we are going to use these types of tapes. Next, coming to the second one, metallic tapes. Okay, the metallic tape. Okay, this is one of the second types of tapes based upon the material. The metallic woven tape is improved version of linen tape. Okay, this is one of the tapes which is used in the surveying. This is one of the improved versions of linen tape. Okay, and brass or copper made wires are used as a reinforcement for the linen material. So here you can see the linen type material tape. Okay, and here the brass or copper wires. Okay, here if you see, the brass wires or copper wires are used as a reinforcement to improve the durability, or else to improve the quality of the tape. Hence, it is more durable than normal linen tape. So, due to the arrangement of these reinforcement around the tape, this particular durability of the tape will be improved. And a brass ring is provided at the end of the tape, which is included in the length. So, at the end of the tape, here we are going to place a brass ring, and this is also calculated while measuring the lengths. Okay, while measuring the lengths from different points, we are going to include the brass ring also. Okay. Next, these tapes are available in the lengths of 2 meters, 10 meters, 15 meters, 20, 30, and 50 meters length. Okay, and these are used for survey works such as topographical survey works. Okay, where the minor errors are taken or not taken into the account. Okay, we are going to use to create the topographical maps. Okay, whenever you are going to do this particular type of survey, we are going to use this metallic tapes. Here we are not going to consider the small errors. And third type of tape is steel tape. A steel tape is made of steel or stainless steel. Okay, the metal used for this particular type of steel tape is steel or stainless steel, and it consists of steel strip of 6 mm to 10 mm wide. Okay, we are going to use the width of around 6 mm to 10 mm width. Okay, here you can see the steel tape which is shown here, and it is available in the lengths of 1 meter, 5 meters, 8 meters, 10 meters, 20 and 30 and 50 meters. Okay, these are the different lengths which are available in the steel tape. And next one, meters, decimeters and centimeters are graduated in the steel strip. Okay, on this particular strip we are going to have the units also. And next, steel tapes generally came up with a metal case with automatic winding device. So if you see, this is the device which is used for folding this particular tape automatically. Okay, and the tape is withdrawn from the case by using hand during the measuring, and it is rewound into the case by just pressing the button provided on the case. So if you see this particular image here, when you take out this particular tape, we are going to use the hand for taking out that particular tape, and when you want to wound that particular tape after completion of the surveying, you just have to press this button so that it is automatically going to wound the tape. And steel tapes are not flexible. Okay, they are not flexible, and we cannot use these particular tapes in the undulated surfaces. We can use these particular types of tapes only on the leveled surface. Okay, wherever the surface is very flat, there you can use these particular types of tapes for measuring the distances, and they may corrode easily when exposed to the moisture. Okay, if you do the surveying in the moist conditions, then that particular tape is going to get corrosion, and to prevent this particular tape from the corrosion or else from the degradation, we are going to clean the particular tape, and we are going to apply the oil after every use. Okay, after measuring the distances in the environment whenever it is exposed, then after measuring, you just have to clean the tape and we have to apply the oil so that it is going to prevent the corrosion. And these tapes are generally used for standardizing chains, measurements of construction works. So, due to the temperature changes or due to the some environmental conditions, the lengths of the chains will change. So, for standardization of these particular chains, metal chains, we are going to take the help of these tapes. Okay, and for measuring the small construction works, also we can use these types of tapes. Coming to the last one and fourth one of the types of tapes, invert tape. Okay, invert tapes are made on an alloy which consists of 36% of nickel and 64% of steel. Okay, these are the two particular alloys, metals which are included in the manufacturing of invert tape. And invert tape contains a 6 mm wide strip. Okay, so this is the invert tape you can see in this picture, and this particular strip is made up of the nickel and steel, and the width of this particular strip, invert tape strip, is around 6 mm. Okay, and is available in different lengths such as 30 meters, 50 meters, and 100 meters. Okay, these are the three different types of lengths, and the coefficient of thermal expansion of invert alloy is very low. Okay, when it is exposed to the high temperatures, the expansion will be very low compared to the other metals. Okay, and it is not affected by the changes in temperature. Okay, hence these tapes are used for high precision works because the errors in this particular chains are very less and there is no expansion in this tape. That is why the accuracy in the measurement of distances is very high, and we can use this particular tape in very high precision works. In surveying, such as baseline measurement and for triangulation surveys, we can use this type of surveying tape. And invert tapes. Okay, invert tapes are expensive than all other types of tapes. When you compare the cost of other types of tapes, the cost for the invert tape is very high. And next, these tapes should be handled with care, otherwise bends or kinks may be formed. Okay, while doing the surveying, we have to take care of this particular tape, otherwise you may get the bends on the strip or else kinks on the strip. That is going to cause some inconvenience while measuring the distances. Next, coming to the next part of our lecture, ranging. Okay, ranging of surveillance. Okay, ranging of surveillance is very important in chain surveying. So we will discuss about the definition first. Ranging. So it is a process of fixing or establishing the intermediate points, okay, to facilitate measurement of the survey lines. So here, when you want to measure the distances from particular point to another particular point, suppose point A to point B, here we are going to establish some intermediate points because the distance of this particular line AB may be very large. Okay, so if you want to measure the distances of these particular points, then we are going to locate or establish some internal points, okay, or else intermediate points. So this total process is called as ranging. Okay, and the intermediate points are located by means of ranging rods or offset rods and ranging poles. Okay, these intermediate points, okay, to reduce the effect of errors, we are going to divide this total survey line into the parts by using the intermediate points. So these points are established by using ranging rods or else offset rods and ranging poles. Now, ranging out survey lines. Okay, see, while measuring the survey lines, the chain or tape has to be stretched along the survey line along that joins two terminal stations. So whenever you want to range the survey lines, here we are going to take two endpoints. Okay, when you want to measure the distance from this point to this point, we are going to place the chain or tape, okay, which is stretched without any undulations or without any sagging. Okay, we are going to stretch the tape, and when the line to be measured, okay, when the line to be measured has a smaller length compared to the chain, then the measurement goes smooth. Suppose this is the Suppose this is the line you want to measure, okay, and we have the chain length of around, I mean, more than this particular line. Suppose if this is, assume this as a chain. Okay, now if the length to be measured is very small than the length of the chain, then it is very easy, within one mm, action we can complete the measurement of chain. But when the measurement of the line is more than the chain length, then we are going to establish the intermediate points. Okay, we are going to establish the intermediate points before conducting the chaining process. Okay, before placing the chaining process, we have to divide this total length by using some intermediate points, so that we can measure the distances very easily if it is more than the chain length. Okay, this total process is called as ranging. Okay, so if when the line to be measured has a smaller length compared to the chain, then the measurement goes smooth. And if the length of the line is greater than the chain line, okay, then we are going to establish some intermediate points before conducting the chaining process, and this total process is called as a ranging. Now, coming to the next one, the process of ranging can be done by two methods. Okay, we are going to do the ranging for surveillance by using two methods. The first method is direct ranging, and the second method is indirect ranging. Okay, so coming to the direct ranging in detail, see, when the two survey stations are intervisible, that is, the two endpoints of the survey line are visible, direct ranging is used. Okay, suppose here we have point A and here we have point B. Okay, and if you see from here, okay, these point and this point are both are visible. Sometimes if the distances are more, we cannot see the other end point, okay, other station point. So there we are going to use other types of ranging methods, but here these 2 points are visible, then this particular type of ranging is called as direct ranging. Okay, direct ranging can be done by eye or with the assistance of an eye instrument. Okay, so this particular direct ranging can be done with the use of eye, or else by using the eye instrument. Okay, and it can also be of two types. Okay, we are going to have two types in direct ranging. First one is we can do the ranging by eye, or else we can do the ranging by eye instrument. Now coming to the first one, direct ranging by eye. See, this type of ranging is carried out when the survey stations are visible to the rangers or surveyors. Okay, this particular type of ranging is done when the two survey stations, like suppose if you take point A and point B, these two stations are visible. We are going to use this direct ranging. See, for example, take a line AB. Okay, I am going to mark point A and point B. Okay, these are intervisible points. Okay, now see, now we can first, the surveyor is going to stand with a ranging rod at the point A by keeping the range rod at point B. So now before starting our surveying, first the surveyor is going to stand at point A by keeping the ranging rod, and again here also at point B also we are going to keep one more ranging rod. So after locating the point A, okay, after locating the point A and point B with the ranging rods, now while holding the ranging rods, that should be half meter length from the surveyor. Okay, and the assistant then takes the ranging rod and establishes a point in between the A line AB. Now after locating the ranging rods at point A and point B, now the assistant will go to the point P, intermediate point P, with the ranging rod, and this is fixed at a distance not greater than one chain length. Okay, the distance from this particular point A to point B should be less than the chain length. Okay, while establishing the point P with the normal eye adjustment, the distance should be less than the chain length. Okay, and the surveyor can give signals to the assistant to move traverse till the rod is in line with the AB. Okay, so now after positioning the point P, now the surveyor who is standing at point A is going to guide the surveyor who is standing at point P to adjust the position of the intermediate point such that the point P should lie on the line of AB. Okay, until the point moves to the line of AB, the surveyor is going to suggest and they are going to move the intermediate point. Okay, in this way the intermediate points are determined. So like this we are going to establish the intermediate points. First we have to take 2 points such as two endpoints A and B. At two endpoints we are going to place two ranging rods. Okay, one ranging rod will be placed at point B and other endpoint is at point A. Okay, here we are going to place the ranging rod. So we have to hold the ranging rod at a distance of less than half meter. Okay, now if you want to establish a point P, that is such as that is intermediate point. If you want to establish one point, one intermediate point in between the line AB, then we are going to take one ranging rod and ask the particular assistant to take the position at point P randomly at point P with the normal eye adjustment. Now, from particular point A, the surveyor is going to see this particular intermediate point. Who is holding the ranging rod. Now, the surveyor who is standing at point A is going to guide this particular assistant to move the ranging rod in the exact position such that the position of this intermediate point will be located in the line of AB. Okay, sometimes while holding the intermediate position with the ranging rod, sometimes you may stand at a distance of some other places like this. So to avoid this particular inaccurate intermediate positions, now from this particular position he is going to guide to move towards the line AB. Okay, like this we are going to establish the intermediate points. Next, the next type of ranging in the direct ranging is ranging by line ranger. Okay, so in this case intermediate points are fixed directly using a line ranger. Okay, this is the line ranger equipment which is used for establishing the intermediate points. Okay, directly we are going to establish the intermediate points unlike previous method. Okay, the line ranger is an instrument that has either two plane mirror arrangements or two isosceles prisms. Okay, that are placed one over the other. Okay, this particular line ranger is going to have two types of two prisms which are placed one above the other. Okay, and the prisms diagonals are arranged and silvered in such a way that they reflect incident rays. Okay, these prisms diagonals are arranged in such a way that they are going to reflect the incident rays. Okay, we can see the incident objective rays which are coming from the object. Okay, for example, if you consider two survey lines endpoints A and B. Okay, just consider two endpoints such as A and point B. Okay, the surveyor begins by placing two rods at point A and point B. So now at these 2 points we are going to place the ranging rods. Okay, now let's see with the fixed intermediate point. Now just assume one point in between the line AB with a normal eye adjustment. Okay, this is point C. Okay, next, okay, the surveyor then places the line ranger at the intermediate point C based solely on the visual judgment. So now the surveyor is going to hold this particular line ranger at point C with normal eye adjustment. Okay, so after positioning the, see here you can see the picture. This is the point A and this is the point B. Now after positioning the point A and point B with the ranging rods, now locate the point C. Okay, which is called as one of the intermediate points. Now here we are going to place the line ranger. Okay, with a normal eye adjustment. We cannot say that it is exactly on the line. Okay, for establishing that particular position only we are going to do this particular ranging by using a line ranger. Okay, now the lower prism receives the rays coming from the A, which is then reflected by the diagonal AC towards the observer. So here from point A we are going to get the rays of, from point A we are going to get the position of the ranging rod in the prism, lower prism. Okay, we are going to get the image of lower prism. Okay, in the lower prism. And next one, like that. Similarly, the rays from the point B are received by the ranger's upper prism. The diagonal then reflects the ray back to the observer. So from the both the positions, we can see, okay, point from point A from point B, we are going to see these ranging rods in the prism. Okay, the point A will be seen in the lower prism and the point B will be seen in the upper prism. And these two visuals are, can be seen by the observer by standing near the line ranger. Okay. Now, as a result, the observer can see both the images of the ranging rods at point A and point B. Okay. Initially, the images of the ranging rods are not in the same vertical line. See, after seeing the objects, that is the ranging rods, from point A and point B. These are the positions of ranging rod at point A, and this is the position of ranging rod at point B. See, if you see the positions of these ranging rods, they are not aligned in one position, okay, one place. That means the intermediate point is not exactly on the line. Okay, so these positions are not aligned. Okay, by seeing this, you can tell that whatever the position you have taken as an intermediate point, that is not aligned on the line AB. Okay, so for that, what we are going to do, we are going to move the line ranger like this. Okay, on the both the directions, depending upon the alignment, we are going to move the line ranger such that the ranging rod at point A and the ranging rod at point B meets or else vertically aligned at one particular position. Okay, so we are going to move this particular line ranger such that the ranging rod at point A and the ranging rod at point B have to align as a vertical line. Okay, now we can say that the intermediate point or else whatever the intermediate station you have taken, that is aligned on AB line. Okay, this is how we are going to do the ranging by line ranger. Okay, so now once the images are aligned, okay, after aligning the positions of ranging rod at point A and point B, now we are going to use the plumb bob to transfer that particular point onto the ground. Okay, after positioning the intermediate point, we are going to use the plumb bob such that the point is transferred to the ground. Okay, and the main advantage of this particular method over the eye judgment method is that it can easily performed by one person. Okay, in the ranging, ranging by eye. Okay, with eye, if you do the ranging, there we need around 2 to 3 persons. But here, this particular ranging will be completed by using only one person. Okay, and this method also achieves higher level of accuracy. Okay, compared to the ranging by eye, the ranging by linear ranging by this particular instrument is going to give more accurate values. Okay. Next one, indirect ranging. So indirect ranging is employed when the 2 points are not intervisible or the 2 points are at a long distance. Okay, if the 2 points are not visible, suppose if you take the ground as example, here you can see the undulations of this ground like this, and here I am taking 1 point and here I am taking another point. Okay, so if these 2 points are intervisible, so the visibility of this particular point is not not accessible, then we are going to call it as indirect ranging. Okay, this may be due to some kind of intervention between the 2 points. Okay, the invisibility of this particular 2 points may be whatever the, suppose sometimes some trees are available, okay, near the sun, near the environment survey area. So that is the reason this is called as an indirect ranging. Okay, two intermediate points are located. So for example, here we can see one type of surveying, indirect ranging. What is indirect ranging? See, two intermediate points are located, M1 and N1. See, this is the survey to be, this is the line which is to be surveyed, line AB, and here to locate this particular 2 points, okay, to locate or else to measure the length of this particular intermediate points between these 2 points. See, here I want to locate these 2 points on the same line of AB. Okay, for that what I am doing now, Just to draw one line. Okay, take station A and take and end point B. Now locate M1 and N1 very near to the chain line. Okay, now here this is the chain line, right? Now I am going to locate the points M1 and point N1. Okay, these 2 points are very near to the chain line. Okay, such that suppose if you see from M1, okay, from M1 if the surveyor is going to see, he can see the point N1 and the point B. Okay, the point should be such that you can see the point N1 and point B from the M1 position, and also from N1 also you can see the M1 and point A. Okay, such that we are going to locate the points, intermediate points M1 and N1. So after locating the point M1 and N1, here now arrange the two ranging rods at M1 and N1. Okay, take two ranging rods and arrange each rod at position of M1 and at the position of N1. Okay, now from M1, okay, from point M1, here one surveyor is going to stand with the ranging rod, right? So M1, the surveyor who is standing at M1 is going to ask the another assistant or surveyor who is holding the ranging rod at N1 to move the to move from N1 position to the new position, that is N2. Okay, the surveyor who is holding the ranging rod at the M1 is going to guide the surveyor who is holding the ranging rod at the N1 to move to the new position, that is N2, such that okay, it should such that the intermediate point which is located in between the M1 and B should be aligned in the same line. Okay, initially the position of N1 is here, but we are going to transfer this particular point to the new position, that is N2, and the position of this N2 should be in line with the M1 and B. Okay, these 3 points should be on the same line. Okay, now after locating the point N2, that is intermediate position between M1 and B, now the surveyor who is holding the ranging rod at the N2 will guide the surveyor who is standing at the M1 to move to the new position, that is M2. Okay, so he is going to guide the surveyor who is holding the ranging rod at M1 to move to the new position, that is M2. Okay, and the position of M2 should be in same line with the N2A. Okay, the new position of M2 should be in the same line of A N2. Okay, this is the new position. Like that, the same procedure will be repeated until you get the positions of N1 and M1 on the line AB, such as M and N. Okay, first we are going to take the positions of M1, okay, and N1. Okay, and we are going to transfer by using this procedure to move the positions of these M1 and N1 to M and N. Now these are the intermediate positions. Okay, these are the intermediate positions by using ranging. Okay, indirect ranging. Okay, now errors in ranging. So here we are going to get the following errors. See, incorrect adjustment of ranging rods between two survey line points. Okay, here this occurs when the ranging rods are not vertically aligned with the survey line or form an angle in their correct alignment. Okay, and next one, inaccurate reading in mountainous areas due to change in elevation of the ground. Okay, so in these areas the survey line's angle is not correctly determined by eye or by the light of reflection from mirrors. And next one, loss of sight of one survey station. Okay, loss of sight of one survey station. So this occurs when surveyor losses sight of one survey station, usually due to certain trees being between the two stations. So whenever you have any trees in between the two survey stations, you may lose the sight of the other end point. Okay, and wandering. So this is mainly caused by the inaccuracy of the instrument. So inaccuracy of the instrument is going to cause the movement of the survey stations or positions. Okay, used for ranging, and also by the surroundings. especially if trees or buildings are present in the close proximity. So if the buildings or trees are nearly available, then due to this we will be getting the wandering. Okay, the possibility of wandering increases if it is cloudy day or under artificial light. Okay, if the lighting is not good also, we are going to get the wandering in the survey. Now, errors in chaining may arise from the following reasons. So, whatever the errors we are going to get, like incorrect measurements in the surveying, chain surveying, we will see incorrect length of tape or chain. If the length of the chain or tape is incorrect, then we are going to get the inaccurate results. Okay, and improper ranging. If the ranging is not done, okay, if the sighting of object from the different positions is not done properly, then we are going to get the errors. And then carelessness in holding or marking. So while holding the chains or tapes, we are going to have different different positions. Some people will not hold the tape or chain properly. Okay, you may get sagging in between the chains or tapes. Okay, we have to avoid the particular carelessness. We have to stretch the tape or chain carefully to get the accurate results. And next, sag in chain. Okay, if you are not going to hold the chain properly like this, okay, this particular position is called as a sagging. Okay, and temperature variation. If the temperature variation is high, then it is going to affect the lengths of chains or tapes. And personal mistakes like misreading, miscounting by loss of arrows. Okay, reading of chain wrongly. Okay, these are the personal mistake. Okay, you have to read the measurements carefully, and you have to place the arrows in between the intermediate points at the intermediate points carefully. Okay, thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.